What's the core idea here?
The paper presents RecurrentGemma, an open language model that takes a slightly different approach than the typical transformer models we see today. Instead of relying entirely on global attention mechanisms like in transformer models, RecurrentGemma combines something called linear recurrences with local attention. And this blend offers a couple of advantages. First off, it performs pretty well on language tasks, and secondly, it's more efficient, especially when dealing with long sequences of data.
Can you elaborate on the efficiency aspect? How does RecurrentGemma manage to handle long sequences better?
Good question. You see, traditional transformer models require a growing amount of memory to process longer sequences. This is due to what's called a KV cache, which grows as the text input grows. This can be a bottleneck when you're working with, say, a large article or a book. RecurrentGemma, however, compresses these input sequences into a fixed size state. This means it doesn't need a progressively larger memory footprint as the text gets longer. And a nice bonus is this allows it to work well on devices with more limited resources.
So this fixed size state, is it kind of like a summary of the input?
It is in a sense. Think of it as the model's way of remembering what it's seen, but in a very concise manner. It captures the essence without getting bogged down in every single detail. It's a bit like the summary you'd write for a long article, but done through matrix and vector operations.
Now, how does RecurrentGemma's performance compare to traditional transformer models like Gemma? They mentioned Gemma a few times in the title and abstract.
The results are encouraging. RecurrentGemma achieves results that are competitive with transformer models like Gemma, even when trained on fewer tokens, which is a good result.
What do they mean by tokens?
A token is a way of representing a piece of text. In a large vocabulary, a token can represent a word or even a part of a word like prefixes or suffixes. This breaks down the text into manageable chunks for the model to process.
The paper introduces both a pre-trained checkpoint and an instruction-tuned checkpoint. Can you explain the distinction?
Certainly. The pre-trained checkpoint is essentially the base model. It has learned to understand and generate text from a large dataset, but it's a generalist. The instruction-tuned checkpoint, on the other hand, has received additional training specifically to follow instructions and engage in dialogue. It's more specialized to interact in a conversational way and follow your instructions.
That leads nicely into my next question. The paper discusses instruction tuning and RLHF reinforcement learning from human feedback in the training details. How does this process work?
The researchers followed a process similar to other instruction-tuned models, and that involves training the model on a data set of instructions and desired responses. RLHF comes into play by incorporating human feedback to refine the model's responses. Humans rate the outputs, and then this data is fed back into the model. It's a bit like a teacher giving feedback to a student on their essay.
Fascinating. So, in essence, RecurrentGemma aims to bring the power of language models to more people and devices and situations. Does the paper talk at all about responsible AI development, ensuring things like fairness and privacy?
The paper does address the importance of responsible deployment and highlights safety measures taken, including evaluations of the model's responses to prompts with unsafe content or biases. The paper notes that an independent team also conducted ethics and safety evaluations.
That's good to hear. Lastly, what do you think is the main takeaway from the RecurrentGemma paper?
I think RecurrentGemma offers a glimpse into a potential future for language models where efficiency is a key consideration. By moving past the limitations of traditional transformer models, we can start to envision language models that are not just powerful, but also accessible.
That's all for now. Thanks for this insightful discussion.